In this video, I will consider one numerical on reciprocity theorem. Determine the current I in the network shown below and verify reciprocity theorem. So here this is the given circuit. We have to find current I. Once if I calculate current I, then we have to verify reciprocity theorem. So in reciprocity theorem, first we have to find the current I for the existing circuit. Then later, let me consider this is branch AB where voltage source 10 volt is connected, branch CD where current is flowing. So in reciprocity theorem, we have to interchange current and voltages. That is, in second stage, we have to connect this voltage source in series with 2 ohm resistor. Then we have to find current in branch AB. So this current and the current with the existing current should be same. Then we can say that this circuit obeys reciprocity theorem. So first let me calculate I. So here this I can be calculated using many methods. Here we can use loop analysis or node analysis or directly by using current division rule. So I will try to simplify using loop analysis. Let me assume current in this branch is I1 and let me assume current in this branch is I itself. That is I current is flowing. So current in this branch is I itself. I will apply KVL to loop I1. So that is apply KVL to loop I1 so that I can write 10 is equal to, we have 2I1, voltage across 2 ohm resistor is 2I1 plus voltage across 3 ohm resistor is 3I1 minus I. Let me simplify. 10 is equal to, this is 2I1 plus 3I1 minus 3I, or 10 is equal to 5I1 minus 3I. Let me call it as equation 1. Now similarly apply KVL to loop I, that is apply KVL to loop I. So here in this loop there is no voltage source, so I can say voltage is 0 is equal to, so voltage across 2 ohm resistor is 2I, voltage across this 2 ohm resistor is also 2I, that is I can write 2I plus 2I plus voltage across this 3 ohm resistor is 3 into I minus I1, because current I is flowing bottom to top, I1 is opposite to that, so it will be 3I minus I1. Let me simplify this. 0 is equal to 2I plus 3I minus 3I1, or I can write 0 is equal to minus 3I1 plus 2 plus 2 plus 3, that is 7I. Let me call it as equation 2. So now solve equation 1 and 2, that is solving equation 1 and 2, we get, so these two equations can be solved directly using calculator. Keep calculator in equation mode and choose two unknowns. Here we have two unknowns, I1 and I. So here coefficient of I1 is 5, coefficient of I is minus 3, and this value is 10. In this equation, coefficient of I1 is minus 3, coefficient of I is 7, and this value is 0. Just feed the values in calculator. You will get I1 is equal to 2.692 and I is equal to, we have 1.1538 amps. So this is the required result I. So now let's verify reciprocity theorem. So now to verify reciprocity theorem, I have to connect this 10 volt voltage source in series with 2 ohm resistor, and we have to short this branch and we have to find current through branch AB. That is, the circuit looks like this. I have shifted 10 volt source here. So this was terminal AB, this was terminal CD. Now we have to find this I. So this I and the previous I both should be same. So now again I will solve this using loop analysis. That is, let voltage across current through this branch is, this loop is I1. Let current through this loop is I. Apply KVL to I1. That is, apply KVL to loop I1. I can write 10 is equal to voltage across this is 2I1 plus voltage across this is 3I1 minus I, and voltage across 2 ohm is 2I1, or I can write 10 is equal to 2I1 plus 3I1 minus 3I plus 2I1, or I can write 10 is equal to, this is 7I1 minus 3I. Let me call it as equation 1. So now similarly apply KVL to loop I. Apply KVL to loop I. So here there is no voltage source. I can write 0 is equal to voltage across 2 ohm is 2I plus voltage across 3 ohm is 3I minus I1, or I can write 0 is equal to 2I plus 3I minus 3I1, or I can write 0 is equal to minus 3I1 plus 5I. Call it as equation 2. Now solving equation 1 and 2, that is solving equation 1 and 2, we get, so here also simplify this directly using calculator. So here coefficient of I1 is 7, coefficient of I is minus 3, and this value is 10. In second equation, coefficient of I1 is minus 3, coefficient of I is 5, and this is 0. So solving this, will get I1 is equal to 1.923 amps and I is equal to 1.153. I is equal to 1.1538 amps. So here we can observe that finding current through this circuit is 1.1538, and finding current through this circuit is also same. Therefore, it verifies reciprocity theorem. Hence, reciprocity theorem is verified. Thank you for watching.